Welcome to this Sahara 4 exercise. In this exercise, we will open the Wellworks window that shows the different jobs that were performed over time in each well, along with the different installations that we have imported as well. The position of the tubing, the casing, the pump that we may have, or the injection installation, the mandrels, and so on and so on. The layer schematics, the electrical logs, the petrophysical and production data, and user notes can also be displayed in this Wellworks window. For this exercise in particular, we will use a pre-created template, but we will see the different options that we may have by clicking in the different menus. So we will open our Sahara project, and once here we will go to View, Wellworks, and this will open the Wellworks window with a predetermined template. In this case, it's only showing we have only one track here, the general settings track, and we have the minimum information that is always going to appear in the Wellworks window. That will be the depth. In this case, we are using the MD, but we can change that. Here we can see the main scale. We can modify it as we see fit. In the case that we have the datum of the well, we can use TBD sub C without any issues. And we also are going to check on the layers. Here we can see the different layers, which each top and bottom and base, is defined by the by the petrophysical data that we imported in exercise 8. And here we see the information that we imported in the last two exercises. On one hand, we have here, for example, the perforations, where we can see the status and the depth of the perforation. Here we can see the perforations that are in black. They are active at the time of the well work that we are checking, and the ones that are in red are inactive. In this case, because they are under a plug. Here we can see the position of the plug. Um, Here we also have the tests. Here in the test we can click here and see the different results, the test date, if the result was oil, water, or which exact result we have, the the different rates of the result, the water cut and the level, and the other information we may have. If we have salinity, we can check it as well here. Automatically, the bubbles here that are associated to the tests are going to show the percentage of water cut seen here. For example, we can quickly see here that for example, this layer 18 had this perforation at this date, the one that is associated to the well work, and it has this water cut, which means that this layer brought us plenty of water and just a little bit of oil. And also we have the wellbore diagram. We can see the plug here that was part of the example. Here we can see the circle rod pump with the information associated, the offset diameter, the string, and here we can see the casing as well. The casing and the packer, that we can also view it here, that we have a packer at this depth. Casing and the tubing here and the casing here, the casing, the external one. So those are like the general options that we will review when we open the Wellworks window. We can load templates here. I have a predetermined template here created previously that we will open. And here we have a little bit more of information. We see that the general Wellworks information that is portrayed is the same. We have our tests here, the perforations, the wellbore diagram, the position of the casing, the tubing, the plug, and the layers as well. But we have added the information that belongs to the logs, to the electrical logs that we imported in a previous exercise in this project. So let's check the different options that we have. Here we can create a new template here. We can load previous templates or save them. Here we can lock and unlock the selection. This means that if we lock it here and we select any other well, this window is going to refer always to the same object. It's not going to change by changing the object selected in other windows. Here we have the selection. Here we can select which group of wells we want to check, and here we have exactly which well we are reviewing. So here we can check on any well and see um, the different logs on the right, on the left side, the layers here, the perforations, the wellbore diagram, and the tests on the right. Um, Here we have some more options here. I want, before seeing other options, I want to see here, for example. Here we have a well that has three different well works. We have well work number one, number two, and number three, and that's why I explained earlier that it's important to have the interventions that are done in each different well work to have it correctly associated to your well work. In this case, we can see that we did have these perforations here, then we have these perforations here. For example, the perforation in the layer 9 was added at this date in this well work. The one 2017 was a change from producer. We have this installation here is belongs to a producer. Obviously, we have a pump here, and here we have the change to injector, where we have a system of packers and mandrels. Here we can see the mandrels, for example. Here we have the information of the mandrel, the commentaries, the outside diameter, the date where it was added, and we can see the change in the installation of the well from producer to injector. Here we can see that we have a fill. That means that we probably will have sediments here or any other. From this depth onwards, we cannot reach the bottom of the well. In this well work was probably checked that we try to reach the end of the well, and we for some reason we have filled up to this point and we cannot reach these perforations here, and they are closed. But later on, when they modify it to injector, for some reason they could clean it this, maybe they did a cold tubing or something similar, and they managed to clean all this fill here, and they could reach the end of the well with the selective installation of injection. So that's why it's important to have your well works correctly organized, because it's going to differentiate what are you going to see in this window here. So we can see that we have plenty of information here. Now we will keep reviewing the options. Here, for example, we have this fixed vertical scale. This will allow us to, when we modify from one well to the other, to keep the same scale. This might be useful if you want to see, for example, a specific depth in the project, and see how the different well works are in that specific depth on that group of layers, for example. We have this button as well here that will show or hide the logs that we have added with the tree structure here by adding tracks and adding curves. We can see either hide or show these logs with this button. Also, we have this button here that will allow us to copy this picture, this diagram, as a picture in the clipboard, so we can copy it maybe in another file, in a PowerPoint or something like that. We here can select which of the interventions we want to see. Here we have this one, this one, this one, and we can see each of them separated, or all of them at the same time. Here we can select the last one and then each one separately. We can see a different well works with that, and we can use these buttons here to switch between them more quickly. Here we can also open this table here, where we can see all the information that has been imported in this well, in the well work, for the well work window, and we can modify it by using this table here. Here in general settings we have plenty of other options. For example, we can add a secondary scale here. For example, if you want to check in meters, in measured depth, we can also use TBD sub C, also in meters, and see both of them in the scale with the conversion using the datum. Here we can switch between having or not the header. That's very similar to what we see in the log window. Many of these options are the same. Here we can add the peaks for this area that is the same as the log window as well. We can add here. We can also, with this button, add the logs and decide how much width we will have here. For example, I want to increase this because so I can see, for example, the values that are being currently selected in the resistivity. I can do it here with this option here in the middle. So I have plenty of space for my logs here. Here we can hide the wellbore track that will show the layers. We can hide the layers, we can hide the picture of the layers and have only the logs and the interventions. Here we can take away the status of the perforations. So if we do it, we will see that we don't have the perforations plotted. For the diagram, we will remove completely the diagram. All the facilities of production or injection of the well will be hidden. Here we can also affect the width of the right side of the well work window by increasing the width here with this option. We can add text, and here we can see all the information that relating to the tubing casings. In general, the wellbore diagram will be shown with this option. We will see the name of the piece, the depth of it as well. For example, in the case of this pump or this anchor, we will see the depth and where the piece is located. And in the case that it has a continuous depth, we will only see the outside diameter that is defined for the casing and tubing, for example. Um, so that will be it for that option. Here with job, we can hide or show the different tests that were done. Here we can hide the bubbles as well. Here you can see that I'm hiding. In this case, what we are seeing here is that the there were a number of perforations here that we can see in this green color. We can modify in which color each of the different jobs are plotted. In this case, by default, we will have the perforations in green, the cementations in red, and the interventions, like for example acid jobs or stimulation in general, will be in yellow. You can modify this by going to variables, and here in Wellworks you will be able to check on the general operation, intervention number, Wellwork start date, job start date should be over here. Maybe no, Wellwork diagram is not the option. Here it is, operation. Here you can modify. Here you can modify plenty of things. For example, you can modify the color. As you can see, as I said previously, perforation, squeeze in this case cementation, is going to be considered in red, perforation in green, formation test in green, and stimulation in yellow. But you can modify this. We edit here and modify this the color here, and you can also modify the keywords that will be used when importing the different kind of jobs. Obviously, you cannot here add new jobs because these are like the internal structure of how the well work window works, and you will need to include. You only can work with these four groups by default. So we won't save the changes here, but just for you to know that you can modify the colors using that option in variables. So as I was saying here, if you click on hide the jobs and the bubbles associated to the test, here I have two perforations that we can see here, perforation number 1 and perforation number 2. Here this parenthesis here is going to show that the formation test, also in green, will include these two perforations here, and the result of that test is going to be the one that is shown in the bubble. So we can, for example, hide the bubbles only or hide the whole job description. In this case, all the information about that there was a cementation that you have perforation there, and that it was tested will be hidden. We can also click on sequence here, and this will show the sequence in which the different jobs were done. I mean, in this case, we know that the first thing here, all these perforations were done in the same order. Like everything happened at the same time. Everything was perforated at basically the same time, the same interval. That's why this started at 4. Then, in this case, this test was done first. That's because it's number 5, number 6, number 7, 8, 9, and 10. So all the perforations were done at the same time in terms of this well work, and then each test was done this one first, and then from bottom to top all of the tests. And we can see that this other perforation here, we added this perforation. It was the last thing to be done in another different well work, and that's why it's the number 11 in the sequence. That means that it happened later than all the other things done in this particular well. So yeah, that will be the sequence. And here, in the case that you have comments, you have imported, you can import comments that have depth, that have top and base. You can show them with this option here, and you can see the different type of comments that can be shown. In this case, we haven't imported any for this example, so we won't see any in this case. So then the other options associated to the logs are going to be pretty much the same that we have discussed in the previous cases, in the previous uh, well log window in previous exercises, so that won't change much. I mean, everything is pretty much the same. You can define, you have logarithmic scale, the units, which curves are you going to use, if you're going to use mnemonic, alias, and that what we discussed in that particular exercise. So in the case that you have any doubts about how to plot your logs along with your Wellworks, please feel free to go to those exercises where we discuss the configuration of the log window. Regarding the Wellwork window, I think that will be everything for this tutorial. Remember, maybe it will be good if we find any well that has before we leave, find any well that has a cementing job done. Let's look for it. Here we have more complex installation. Here we have, for example, we have a fish here that couldn't be recovered, and a plug that's going to be used. We are going to use that symbol in this case, and the perforations that are under this fish are going to be not available. They are not going to be active, so that's why they are in red. And here these perforations are seen as closed because they are also involved in this fish in particular here. So let's look for cement job. We need to have some. So well, for example, we have a casing leak here, and all the and all the perforations in this well are not active. All of them are inactive because we have this huge casing leak here, and the well had to be abandoned. As you can see, we have a plug here, and everything below the plug is pretty much abandoned. So let's look. Let's keep looking. We have more perforations, more tests. We can see that in many cases we have a single test with a lot of perforations involved. In this case, all these perforations here were tested together, so they have this whole test here with this green color as well. And let's keep looking for a cement job that we can check. We have plenty here. We have a very complex installation of selective injection, for example. And here we have an example of a cement job that I wanted to have a example of a squeeze, a cement squeeze, before we leave this tutorial, this exercise. So in this case, you can see that the first well work is in 2005. This well was open in all these different layers here. We have this perforation, this perforation. These ones in gray are not as close, and here we can see that there was a cementation done here in that date, and there was, let's see the sequence so we have clear how things, in which order things were done. Here we can see that first these two perforations were done. That's the first step. Then number 5, we have these cementations here. That means that the layers were cemented. Then there was a test done here where we have a lot of water. Basically the result was considered not applicable, so the result was not conclusive, but we have plenty of water coming here and nothing of oil. And there was a second attempt to cement this layer, and then the layer here on tops, the number 7, was perforated. And then another test was done, and then we have a lot of water, and that it wasn't a good idea to perforate this. However, the test was done later. We see that here all these perforations were done together, and then they start doing the test, finally reaching number 19 and seeing that all this area on top has just a lot of water. So, and at the end they decided not to cement it again, but we can see that it would have been a good idea in this case. The important thing here to consider is that because we did these perforations first and then there was a cementation here, now this perforation, their status is closed because they have been cemented. Then we did another try, another cementation, then there was another perforation here, and this perforation was never cemented. So even if the test is pretty bad, because we see that we have basically 100% water coming here, as this layer was never cemented, it's going to be in status open and it's going to be in black. So that means that this perforation is still open up to the present, and in the next well work, this information is going to carry on, and we can see that we have these two closed because they were cemented previously, and this one is still open. So I wanted to have just one example with a cementation, so you can see how's the dynamic, how the information evolving dynamically over time, and how each of why the sequence is so important. Because imagine if I did this one, all these things that happen in the same well work. So imagine if instead of having this as the step number 7, I have it as the step number 9. In that case, this cementation would include this perforation that was done later, and now I will have the wrong information telling me that this one, and this one are closed when only this and this are closed. So that is important. That's why it's important to have your sequence number correct, that have your information checked before you import it. So because in that case you will have the right status for each perforation, and all the information will work correctly to show you the right diagram. And then maybe you use this information for example, there are other calculations that you can do. For example, check how many meters of a layer you have perforated, and the things that are cemented are not going to be considered, but the one that is open, it is going to be considered. So in that case, for many other interactions in Sahara, it is important that if you import and use Wellworks, they are correctly imported. So that will be everything for this tutorial, and thank you for watching.